Greetings. Today we're going to talk about uncertainty calculations, and basically what this involves is looking at the effect of measured values and the uncertainties you get when you take a measurement and how they have an effect on calculated values. And so what we want to do is get a handle on this, and there are rules and regulations for doing it, but for right now we're going to use a technique that I lovingly refer to as the brute force method. Now, the brute force method works all the time. It just is very tedious and can take a long time to do. So again, we want to make sure that we know if we take something that's measured and we calculate something, what's the effect on the final result based upon all the information that we have here. So the example that I am going to use is looking at the dimensions of a piece of paper. And so a regular 8.5 by 11 piece of paper. However, I made the measurements using a ruler so that the values become 27.99 plus or minus 0.02 centimeters. And the 0.02 centimeters comes about because of the divisions between one line and the next on the meter stick, and I can estimate a little bit, and I feel comfortable that I could repeat this measurement and get within 27.99 high by 0.02 or low by 0.02. For the width, the same idea applies, 21.66 plus or minus 0.02 centimeters. Now, once I have the dimensions of the paper, I could also do things like find the diagonal, find an angle. I could even look at what I'm calling the trim piece. I'm going to remove or cut off a piece to make this a square. And I'm going to look at all the different properties mathematically that I can use uncertainty calculations for to see how I can get an uncertainty in the final result. Before doing that, one of the things that I want to make sure we are clear on is that we are dealing with a value that can range for the length from 27.97 to 28.01. That's what I mean by plus or minus 0.02. The same is true for the width. It's 21.64 all the way up to 21.68. So we've got to keep that in mind, that I can have a low value and I can have a high value, and how does that combine when I do my math? So the one math that happens quite frequently is looking at conversions. And so we have our length, and it's in centimeters, but we know that a lot of times we need our length in meters. So we would have our one length, our high length, would be 27.97 centimeters, which is the same thing as 0.2797 meters. And in our low value would be got these backwards, high, low, and then this would be 28.01 centimeters. After conversion, 28.01 meters. And so I have gone above the length measurement by 0.0002 meters, and I've gone below it by 0.0002 meters. And so my uncertainty in the length would become 0.0002 meters plus or minus, because I could go up by that amount or down by that amount, which is the same thing as taking the value for my uncertainty and converting that. So all I had to do was divide my value by 100 to convert my value to meters, but then I can also do the same thing for simple conversions, just divide by the appropriate constant. But then there are other constants that you have to worry about. What if I wanted to double the length of my piece of paper? And so if I wanted to look at 2L, okay, 2L would end up being 55.98 centimeters. But if I put in the low value, so 2 times the low value, I would get 55.94 centimeters, or a difference of 0.04 centimeters. And if I did the high value, I would get 56.02 centimeters, a difference of 0.04 centimeters as well. One is high, one is low, and all I did by multiplying my value by 2 was also multiply my uncertainty by 2. So when I'm dealing with constants, whether it's for conversions or multiplying my value in an equation, then I would just multiply my uncertainty by whatever the constant is. So more happens than just simple constants. So if I wanted to find the perimeter of my piece of paper, I could write my mathematical equation as 2L plus 2W, and I could calculate the perimeter. In this case, I would need to put in, if I wanted to find the biggest value for the perimeter, I would find out what the highest value is for my length and my highest value for my width by looking at my ranges, and add those two together. And I always have to have paper, because otherwise I would not remember. So my highest value would be 99.38 centimeters. I can do the same thing for the lowest value. And when I calculate that out, 99.22 centimeters. So I have a range of values where my calculated value should reside. So when I calculate this out, just based on the values that were measured, then the measured value would be 99.3 centimeters. And I can see how high this is deviated from the measured value, how low it's deviated, and I can see that this went up, could go up as high as 0.08 centimeters or down by 0.08 centimeters. So this becomes pretty easy to determine the range and also the uncertainty. My value is somewhere between those two extremes.